All right, we're going to do some practice problems with significant figures. Try to go through those again. I'm sure that some of you were a little confused as you read through that. And I took some pictures of the book, so it's not the clearest thing in the world. If you want to follow along, we are in the book. This one is page 68. So if you want to go to the book and follow along. And let's just go through the sample problems. It talks about how many significant figures are in each measurement. Well, in the first one, the really easy thing to think about is every number 1 through 9 is significant. So this one would have 3 significant digits. The next one, when you see anything in scientific notation makes things really easy because I would never write those zeros in there if they weren't important. And so on this particular one, they're all going to be significant. You can also just think of it too, is they are what I call trailing zeros after the decimal point. Trailing zeros after the decimal point are significant. This part is never anything we worry about. That's just telling us what place, where the places are. So we're just looking at that first part. And in this one, we're going to have 5 significant digits. Let's just kind of jump down to this one over here. The difference between these two is these zeros are not after the decimal point. They are trailing zeros, but they're not after the decimal point. Therefore, those aren't significant. So in this one, there's only 2 significant digits. Going back, I guess I've been jumping. I'm kind of going down here. Let's go over to B, I guess. On B, 40,506. Remember, all the 1 through 9, those are always significant, so that's easy. And then anything in between is always. So this one, 5. Okay, we did C. If we talk about D, D is, you got to look at it. It says 22 meter sticks. Now understand that when we're talking about meter sticks, and I say I got 22 of them, I'm not measuring that. I am counting that. And there's a difference. What that means is there are exactly 22. Therefore, this is infinite or unlimited. There is whatever I want. So there's an infinite number of significant figures in this particular one. Going to E, okay, we can figure out easily those two. Those are significant. We know that anything in between is significant. So we know those for sure. Preceding zeros, these guys right here, never. So those aren't. Trailing zeros after the decimal point, yes. So this one has 4 significant digits, and we've already done F. All right, what I want you guys to do right now, stop the video, do these 2 problems, and we'll come back and talk about them here in a little bit. They're a little hard to see up here, so it's probably easier to do it out of your book. All right, so for these, in the first one, we know those 3. That's pretty easy. Trailing zero after the decimal point, yes. Those 4. Preceding zeros, no. Therefore, we have 4. On the next one, preceding zeros, not significant. Don't ever have to worry about those, so there's 2. Digits 1 through 4, yep, or 1 through 9, all of them are. 4 of them significant digits there. If we look at this one is, we know that, and therefore everything in between is, so there's 5 in this particular example. Down here, all of these are digits 1 through 9, therefore they're all significant. There's 3 of those. Over here, 2 preceding zeros, we don't count those. The other 2 are 2. And if we go to this one, anything in scientific notation, we just count how many there are there. That's just a pretty easy rule. Those are going to be 4. It'll follow the other rules, but just understand that you never write it in scientific notation with any zeros if they're not significant. So it's just easy. Anything before the time sign is always significant. And over here, first one is, those are, everything in between is, therefore there's 4. In this particular example. All right, let's talk about rounding off. And this gets just a little bit harder. If we want to round off each of these measurements, to the proper significant figures and so on. And then it says write the answers in scientific notation. And so the first one, it says, hey, we want to do it in 4. So right now we have 6 from, every single one of these is. So we need to round it off to 4. So that's going to be, somewhere in the 10th place right there. And then just do things normal. Would you round up if it's a 2? No. So that's going to be 314.7. And it asks you to do it in scientific notation. Well, so I have to move the decimal twice, so it's 3.147 times 10 to the second. All right, let's do B over here. Don't have as much room. We want to go to 2, and I'm looking at this. Those preceding zeros are not significant, so the first one is the 1, and the second one is the 7. That's my 2. So that's where I want to go. So you got to first figure out where's my first 2 significant digits, and then I need to round to that place. So what I need to round to is the nearest 10,000, and the 75 after the 7 would mean I'd round up. So I'm going to get 0.0018. That's rounded off correctly to 2 significant digits. If we want to do it in scientific notation, I'm moving the decimal point to the right. I would get 1.8 times 10 to the negative 2. All right, and then the last one, and this one, believe it or not, gets to be one of the trickier ones sometimes. People look at that and they say, oh, 2 significant digits, so I'm just going to round off to 2, and the 7 would have to go up to an 8, so they'll write 88. Well, 88 is definitely not close to 8,792. You still got to keep your place value, so we've got to put in these zeros to mark place, but they're not significant. Remember, they're trailing zeros. They're not after the decimal point, therefore they're not significant in this particular example. All right, once again, would you please do problems 3 and 4, and then we'll talk about it. So stop the video, come back to this in a couple minutes. All right, so if we look at them, and 3 says to round off to 3 significant figures, 4 says to 1 significant figure, and then write in scientific notation. So we're just going to do both steps at the time. All right, so if we're looking at the first one, 87.073, and I want to round it off to 3 significant digits, it'd be 1, 2, 3. There's my third one. So I need to figure out what would happen with that. Well, it's greater than 5 or greater, so it's going to round it up, so it's going to be 87.1. If I want to go to 1 significant figure, so this is number 4 for this one, then I'm looking at right here, just that particular one. I do need to still get the place value. I got to have something here to hold place. So 87, if I were rounded off to the nearest 10, that's going to be a 90, and of course that's 9.0, or actually no, I wouldn't put the 0.0 in this example. It'd be 9 times 10 to the first. Okay, the next one, 4.3621 times 10 to the 8th, and I want to go to 3 significant digits, 1, 2, 3. That's pretty easy. I can round that off. That's just going to be 4.36 times 10 to the 8th. If I want to go to 1, I'm going just to here. That's also pretty easy. Just going to be 5. No, sorry. It's going to be 4 times 10 to the 8th. On C, we've got 0.0. That's a 0. 0.1552. And since this number is a preceding 0, it is not significant. That's not going to count as one of my 3. So here's the first one, second one, third one. That's where I would round it off to. So I'd get 0.0155. And to 1 significant digit, that's going to be this one right here. And the 5 is going to round it up, so it's going to be 0.02. And I need to make it in scientific notation. Got to move the decimal place 2 places. It'd be 2 times 10 to the negative 2. Okay. All right, let's get some space back. Let's erase some of this. Can't keep up with me. And let's do 9009. We want to do this one to 3 significant digits. There's my, right now there's 4 because all those zeros are in between are. And I want to round it to 3 significant digits. It means I need to round off to the nearest 10. Well, 9009 rounded off to the nearest 10 would be 9010. Now notice that this one's significant, this one is, the one in the middle is, and this one is not. So I've got my 3 significant digits that I want to get. If I want to do it to the nearest, or to 1 significant digit, it's just going to be here. It's just going to simply round off to be 9,000, right? Written as scientific notation, 9 times 10 to the 3rd scientific notation. Remember, you're moving the decimal place 1, 2, 3, 3 places to the left, gives you a positive value. E, 1.7777 times 10 to the negative 3, and if I want 3, there's my first 3, got to round it off to the nearest hundredth. 7 is going to make it round up, so it's going to be 1.78 times 10 to the negative 3. And in the other one, I just want 1 significant digit, it's going to round up to 2. 2 times 10 to the negative 3. And you would only write 2, don't write like 2.0 because anything in front of the time sign we think is significant. So if you wrote 2.0, I think you'd had 2, and we don't for this particular one. All right, last one, 629.55 to 3. Well, we're going to go there. And this makes it kind of interesting because, this rounds it up. So I would get 630, but if I write it like that, that says I only have 2 significant digits, so somehow I need to indicate that I have a 3rd one. A common way, this is not the way our book does it, but a common way that you would do that is simply you put a bar over to the top of that 0. That tells you that's significant. I've seen that a lot in a lot of other books. Our particular book just says, well, write it in scientific notation. So it would say write it as 6.30 times 10 to the second. Once again, you wouldn't write that 0 in scientific notation if it wasn't important, if it wasn't significant. So that would work too. So either way, those are correct. If you just wrote it as 630, that was like a test question, that would be wrong because that one only has 2 significant figures. So either way of these I would take, but just as 630 would not be right. If we want to round it off to 1, it's just going to be 600. As an exponent, 6 times 10 to the second. All right. That is the first 2 sections.